So today we're starting a new unit, polynomials. Before you start today's notes, go ahead and take a moment. In the upper right-hand corner of your paper, label Polynomials, Unit 4B, Homework 1 with the appropriate date. Make sure you're setting up your paper for questions, comments on the right-hand side. And then today we're going to talk about polynomial terminology. So a polynomial is a single term or the sum of two or more terms with whole number powers. So this would be considered a polynomial. Once again, we have single terms, and some of them are adding or subtracting. Now, the 4 and the 12 are what's known as coefficients. Those are the numbers that go before your variables, and they're being multiplied by those variables. 5 is known as a constant. It's not associated with a variable, and it's a constant because it's not changing. It's a constant value. The exponents are going to give you the degree of that term. The degree of 4x to the 5th power would be 5. The degree of 12x to the 3rd power would be 3. X squared, the degree would be 2. And x to the 1 power, even though you may not see it, would be 1. So here, what I'd like to do is I gave you some terms, and I pulled all the pieces from this equation. And I'd like to talk about the degree of each term. So 5 is considered the degree of 4x to the 5th power. My coefficient would be 4. The degree of 12x to the 3rd power would be 3. And the coefficient would be 12. For x squared, we have a degree of 2. And then the coefficient would be 1. Keep in mind, if you don't see a number in front of your variable, the coefficient is 1. And then we have a degree. Remember, if you don't see the exponent is 1, so it would have a degree of 1. And because it's minus x, the coefficient would be negative 1. Go ahead and take a moment, pause, copy before continuing on. Now, when we talk about the degree of a polynomial, this is going to be the greatest degree of any term in the polynomial. So here I have several examples of polynomials. We're going to talk about the degree of that polynomial. And when we talk about degree, we're looking for the largest exponent, the greatest degree. And so when we look at our first one, we're looking for the largest exponent of 2. And this will give me a degree of 2. Now once again, our constant term is going to be the term that's not associated with a variable, and that's going to be 7. So for our next polynomial, once again, we're looking for the greatest degree, and that's going to be the exponent of 3. So the degree of this polynomial is considered 3. Our constant term is going to be that number that's not associated with a variable, and here we see the 3. Now keep in mind, because it's subtract 3, that constant term will be negative 3. Now let's look at our last one, and once again, looking for that greatest degree, we're going to see 2. And then for our constant term, looking for that unattached number, and that would be 36. So we not only want to be able to find the degree of a polynomial, we also want to be able to find the standard form of a polynomial. And that's going to be a polynomial whose terms are written in descending order of degree. So I'm going to start with 7x to the 5th power plus 2x squared minus 3. So we know the degree of the polynomial is going to be 5. That's the largest exponent or the greatest degree. My constant term will be negative 3. And I have 3 terms, 3 separate terms that are separated by addition or subtraction. I also have a leading coefficient of 7. Leading coefficient is going to be when your polynomials in standard form, whatever your leading coefficient of that variable is, that's what I'm asking for. So descending order means it's going to be in order from least to greatest based on the degree, so 5 and 2, and your constant is always going to bring up the rear. It's always going to be at the end. So keep in mind the leading coefficient is that coefficient of a polynomial's leading term when the polynomial is in standard form. Go ahead and take a moment, pause, copy before continuing on. So now we want to talk about a polynomial and how it can be classified by the number of terms it has when it's in simplest form. And we're going to talk about 4 specific. We have monomial, binomial, trinomial, and polynomial. Now, a monomial means one term, hence mono. And here's several examples. We could have 8, negative 2x, 3x squared. Means one term by itself. Now, a binomial is going to have two terms, and that's where we see that by piece. And we could see 3x plus 2, two terms, or 4x squared minus 7x, two terms. You're going to see that they're separated by either addition or subtraction. Now, with trinomial, that'll be three terms, and once again, we see the tri piece on this. And so we'll have negative x squared minus 3x plus 9. And we're going to see three separate terms separated by subtraction and addition. Now, a polynomial is going to be referred to as anything greater than three terms. And so here I see 1, 2, 3, 4, 5 terms. So anything greater than 3 will be known as a polynomial. Go ahead and take a moment, pause, copy before continuing on. So now let's see if we can put that vocabulary to the test. Here we have several different types of polynomials. I want you to go ahead and pause the video, and I want you to be able to tell me how many terms you notice, the name based on the number of terms, the leading coefficient as long as that term is in order, the constant term, and then the degree based on the highest degree. Go ahead and pause now and try before continuing on. So how well did you do? Did you make any mistakes? Are there any things that you noticed that you might have made mistakes on? Once again, we will be practicing this in class. Make a star by anything you had problems with it so we can discuss it before beginning our classwork. So here's our try it out. For number 1 through 5, we're going to use this polynomial. I want you to be able to name the coefficients, list the terms, and give the degree of each term. Tell me what the degree of the polynomial is. Identify the leading coefficient of the polynomial, and then identify the constant term of the polynomial. Go ahead and pause now and try this out. Answer will be on the last page before finishing. So here are the answers. See how you did. And once again, make sure you come to class with any questions. Please make sure you've copied everything on this page before closing out your notes.